Okay, so we left off at mushroom, and so basically with mushroom, whew, so with mushroom we have the collision for it calls other mark destroy, other being bullet, and when the bullet hits it, it then destroys itself, but it decrements the health and moves it to its next frame. If health is less than 1, then you just clear the position and report its death to add the point, and then of course mark itself for destruction. And then repairing it itself is setting the frame back to 0 and the health to be equal to 4, as well as calling forth the little explosion effect. And if we check right here, we have the actual poison class, which I derive from mushroom, if I remember correctly. Yes, no, I derive it straight from grid object, and it's essentially the same as mushroom, other than having is poison equals true, as well as using a different sprite sheet set altogether, and it also has a separate initialization to take in the actual health of the past mushroom if a scorpion ran over a damaged one, so that it sets it up to be a damaged poisoned mushroom. And upon destroy, again, it resets it to, not resets it, but it sets it up for to be reused by its factory by having its health of 4 and its collision deregistered. Regular collision, very similar to the other one, except that it reports its own death, which again is the same amount of points. And from poison, we then go to, from poison. From there, we can then check out the physical grid itself. So currently, let me close that real quick. So here we have several functions. It's currently a game object only in that I believe that it needed to be a game object in the very beginning, and since then I've created a controller, which is a singleton, to access all the functions within this actual game object. So within it we have several spawn functions, as well as several delete functions and clear functions, as well as a few checks and a few voids for clearing and saving. Let's just go through it one by one. So upon the very start, if we go through this fast enough, we have we always initialize the area to be 0, and this here creates the actual scoring event to be grabbed later on for actual mushroom respawn. But yeah, for mushroom respawn is what this one's grabbing. So calling spawn mushrooms basically goes through the whole array, and from that whole array we have to take into account that we have to consider the offset value of 1, in that we build a 30 by 29 square to keep the top row clear, and this just ensures that the top row is always clear. Pixel value 16. So along with that, it also checks that if the J you create is within the player boundary, you increment that number so that it saves that data to be retrieved for the flea to spawn later. And that's all within a random roll, and if you fail that roll, then that spot then is just null. This is delete mushroom position, so again, make sure you're considering the offset to divide by the specific pixel value, and then again just go to set spot on the array, mark for destroy, and set it to null. Clear grid is very similar, except that it skips the point of marking for destroy and goes straight to clearing the position and setting it to null, but it also takes into effect decrementing the things the mushrooms in the playing area. Convert grid to float and float to grid. These are simple functions that are used to snap multiple entities directly to the grid, which we'll see later. And then with check positions, we actually use the very functions we were talking about. So no matter what, we have the proper grid unit to check, and upon checking it, we could return either true, false, or false if it all fails. Check poison. Again, we snap it to the grid essentially to look, and we check that specific grid object spots if it is poisoned. If it's true, then return true, false, so on and so forth. Converting it to a poison mushroom is interesting in that we call both of the functions back and forth to ensure that they are indeed snapped to the grid, and as well as it helps with It also helps with the actual spawning of the converted shroom. So upon checking the grid, we have to check that the spot itself is not poisoned and it's not filled by a poison mushroom. And then from there, we take that old mushroom's health and send it to an integer to hold, which we then delete everything in the array, set that part to null, and throwing it into the actual factory to call forth a converted mushroom to take in that previous health. Specifically for if it's a damaged mushroom, that function is very useful. Spawn mushroom at positions very similar in doing the back and forth to make sure it's snapping to the grid correctly, but all it does is it checks that there's nothing there. Like, it checks if my voice. So it's checking if it's not occupying that specific grid area, as well if it's within proper bounds of not being out of bounds, so to speak, of the actual plays area, and from there it will spawn the specific mushroom with the converted values. Spawn block position. This was an attempt at trying to get the blocking letters to work, but right now I am way out of time, and it was a start, but it just didn't fare too well. Anyway, so spawn grid objects is the same function in that it takes your two inputs and it converts it to what it would look like in the specific array. It would clear it out all the way by marking for destroy and sending it to be null, and then it would create a new grid object there. This is for loading, or this is specifically used in switching scenes. So it goes through the whole grid, saves it within an array, and then from that array, if it's empty, it'll spawn shrooms, but if it's not empty, it'll spawn mushrooms at that specific position from said array, or not array, queue. Here's repair mushroom. Repair mushroom itself has it's a double nested for loop in that it scans the whole grid only once for any poisoned or damaged mushrooms, and for it to repair, and then with that it does this function here, which is very similar to the alarm that it calls, in that it goes through each object and sends the repair score as well as the repair noise, and then it pops it after repairing. And the alarm does the exact same thing, but the second alarm of 0.25, once your queue is empty, calls reset wait if you have remaining lives, and then enables the player to respawn Here's grid clean or clear grid, which is used for cleanup, which goes through the whole grid, marks it for destruction, and nulls it out. Here's increment and decrement mushrooms. So we could look at that real quick. Pressing 2 again makes it so it plays without noise. So here we have, there's the respawn animation happening upon death, which also added 5 points each, so that was 15. So this should technically spawn 20, not 20, an extra 10. And then, whoa, I guess I hit that other one too. And yeah, that's that. Where are we now? So now we could go to Centipede. Centipede, I'll be honest with you, it's a complete mess, but each part itself is made from a derived class of Centipede so that it could utilize pointers within it, or Centipede pointers, so to speak. So there's my failed attempt at finding the state machine that broke. But yeah, it's very similar to what we've seen in the past with my very dumbass master cube, copy cube bullshit fun time. But essentially, in the actual, we have an ace shot, which is a death marker, which we'll get to later. Rotation, switches, and movements, which is used in wave stop. Poisoned and previous is always set to null because it's ahead. Set your sprites and collisions. Set the detection range. And the rotation increments, which is partially off. Head is always initially descending because it always spawns from the top unless it is a primed head, which I have set up. Set the positions, and the speed is set specifically to there. This is if you have segments, you call them body to create more and link it to this head. Establish your directions to call forth the direction multipliers. Set the sprite rotations based off of the direction so it faces the correct way. There's your null pointers. Oh, this is essentially to call for the next one to initialize. And this is where Centipede Beat Play is called. And every time it's called, it's it only plays if it was never called before, or if stop is called before it's recalled. This initialize new is used specifically for the factory to take it in, because it can't just recall new again upon recycling. So here you reset it to false, you clear out all your cues, set your rotation switches to what they were, basically all the elements back to what they specifically were, and it spawns it in the location that you want. Again, playing play and notifying Wave Manager that Centipede is created, which has a functionality of notifying when the player could go to the next wave, which we'll get to in a bit. Here's initialize transform. The transform is what sets up the it takes in order cues of in, old, as well as the new next, so that it could rearrange and reset the specific order of what happened, not what happened, of the destroyed head or destroyed body, and send it backwards to convert into a new head, Centipede segment head with, and reconnecting it to the other bodies. And we just have get row, get column. That was used when I was trying to get find a state machine working. Normal move, you've seen this before. Keep a previous, keep a temporary, have row change equals false, and that you're not changing rows. Do all these calculations, which I know you hate, and then store it in the order queue. Again, I know you hate it. Row change is similar, but it does it only on the y-axis. And again, I know you hate it. Again, storing, update, I still haven't changed it. So if it's empty, you